All right, so this is some code that I wrote to basically calculate the algebra of Rubik's Cubes. So I fetched that Go library. It was called Rust Cube because it initially was basically just like a Rust implementation. But I wanted it to be really, really polished, so I eventually switched to Go instead of like learning to do Rust at the same time. So let me do real quick just vi go cube.go. All right, and just kind of show like what this is all about. I have a Rubik's Cube in memory, and it's basically implemented by like a hash table of stickers, and you basically like rotate around the stickers. There's a ton of language tests in here, so that you can see that, for instance, RR, it's to like actually like rotate the cube around. Okay. And things like front face, and then UR, that's short for front, U inverse R. Yeah. It's a shorthand notation for. Let me see if I find an example of where I'm checking to be like this one. Front, RU, and it's basically doing, where's the simplest version of it? Commutator. Front, reverse, and then reverse front. Yeah. Front, right, reverse front, reverse right. And it has a period of 6. And it's just like validating that when you do that, it ended up being like as if you did nothing, right? So that's what all these checks are for. It was a pretty interesting parser to write for the language. So there's post tests. There's like making a new cube from scratch. Only support a regular 3x3 at the moment, because I don't even know how I would draw like a tetrahedron right now. Let's see, and then after like drawing the cube, there's like how we do the turns, and let's see. The parser. This is like the important part, like parsing the language. Parenthesis, brackets, and curly braces are all kind of the same thing, but it does a whole bunch of checks so that it doesn't like bomb out when you make a syntax error and leave your cube half scrambled. It has to be right or the move gets completely rejected. In any case, so parses numbers for like how many times you're going to actually do something. So like let's just like go in here for a moment and just run it. The interesting thing is you can use RL route to make using it simpler. So if I do a well-known canonical move, like for instance F R U R, when I run it, it expands into this more complicated move that would be harder to remember if you didn't have the notation. But if you are a Rubik's Cube person, you actually would recognize what this is doing. This is like after you've solved the first 2 layers and you're trying to get all the color stuff like up, facing up. And of course, normally when you do that, it would normally be on the yellow face. Right. So one thing when you're trying to figure out how a move actually works, you could try down on a separate cube and then swap cubes, so that if you scrambled a cube, see if that's enough. Yeah, that's kind of enough that it looks scrambled. So if you're working on the cube on the right and you're trying to plan how to do something, what you can do is you can swap with this cube, and once you swapped with this cube, you can like plan your moves on the clean cube, and then when you're done planning your move and you figured out like what the algebra of it is, you can apply to your regular cubes. So I just swap cubes. So I pop that off. It's a fresh cube. But if I do FDRLUDB, and then I apply something more complicated, like say FR3U, so if I do this on a clean cube, so if I do, you can actually like see like how it cycles through certain things and use that to plan out your moves. Because for instance, if you do this and you have a scrambled, say you got through the first 2 layers, and on a physical cube, that is by far the easiest part to do, but it just happens to be that because I'm working on, you know, this algebra, in some ways it's actually harder to solve it on the typed in cube. So the last layer in some ways is easier than it is on a real cube. So yeah, just like as an example, you're going through and you're trying to figure out how to get this to solve right, and then, you know, you turn the faces right, and then you got this move that you know is going to go through these patterns, and that is all the stickers being up. So up, so I turn the upper face a bit, and I'm looking at this and go, hey, I'm pretty close to being solved. And then notice that I have 3 moves that are out. So if I do /u, that might be enough. And if I start solving like so if I do say FR3U, right, I can start to learn like how these moves actually work rather than just like going through a book and memorizing them, right? So I can see that the upper right corner of white is already correct, and so if I turn it or I put it up in the upper left corner, then I can just kind of mess with these other 3 pieces in the top and see if I can get them to actually match correctly. So green, red, pink looks like, would it match red, white, and blue? No, the pink stuff is there, so maybe one more rotate and we'll see how things look. Yeah, so I'm still off by 3 pieces. And so, and I happen to know that this twists some of the corners, and so hey, look, solved. But that's what you use it for. That's it.